Hi, this is Mahesh, Embedded Engineer Tech of Loops. Today we are going to make obstacle detection robot or obstacle avoidance robot, which means whenever the obstacle is present in front of the robot, when it is going on forward direction, automatically it changes the path and it will turn around and it will go and continue to the other side. Okay, so this is the obstacle detection robot, which means this robot is also called as autonomous robot, which means we can't guide the robot in order to move. It will automatically move, and whenever obstacle is there, automatically it turns or changes the path, and automatically it turns right direction or left direction. So we are going to make that robot today. So in order to make that robot, we need some stuff. Some stuffs are. So this is a robot chassis. This is the robot chassis. Everything, the motors and microcontrollers and motor drivers and the dummy wheels and IRs that we are going to fix to this chassis. So this is the chassis. So to this chassis we can arrange all these things, and probably we are going to make a 4 wheels robots. These are the 4 wheels. These are the 1 wheel. These are 2 wheels, and these are 2 another wheels. 2 wheels front side and 2 wheels on back side or right side. So everything. So earlier I told you that there is a screw of to the wheel in order to fix the wheel to the shaft of the motor tightly. So this is the wheel. So this is the screw, and this is the motor driver AC. As we know that the microcontroller has no ability to drive the motors directly because of its low current available on the pins of the microcontroller. So we need to connect this motor driver IC. So the motor driver IC will drive the motors from getting the inputs from the microcontroller. So we can give the commands to the microcontroller. According to that commands, it will give the inputs to the motor driver IC. So this is the L293D motor driver IC. So see this. So it requires 5 volts for its operation. It requires 12 volts for the motor operation. So these two are outputs of this IC, which means in the output we are going to connect the motors, and these are the input pins. So the commands from the microcontroller is fed to these pins, right? So upper 2 pins are used for the inputs of motor 1, and the lower 2 pins are used for the inputs of motor 2, and similarly upper 2 pins are for motor 1 outputs and lower 2 pins are for motor 2 outputs, right? So this is robot chassis. So L293D. So these are the dummy wheels that we need to fix. As earlier I said that these wheels only give the support to the robot whenever it going in forward direction and backward direction. So these wheels are not run and not ability to run. This wheel only to provide the support for the robot only. So we have to fix these wheels in front side of the robot. And basically our project is microcontroller based project. This is the microcontroller that we are going to use in our project. This is 8051. So this is the 8051 microcontroller, right? So it is a programmable microcontroller. So it is already programmed. The code is dumped into this microcontroller. So by inserting this microcontroller on the microcontroller board, that we can arrange the robot or we can make the robot, right? So this is the 8051 microcontroller. So basically this is Atmel 89S52. The number is Atmel 89S52. This is the 8051 microcontroller. 851 family based microcontroller. So this is the 8051 microcontroller board. So here these are the this board contains 4 ports. This is the port 1, this is port 3, and this is port 0, and this is the port 2. Port 0 we have to connect a resistor pack. So the black color one thing is there in the black color, that is the resistor pack that we need to connect to the port 0 of the 8051 microcontroller board. And this is the power supply of the board, right? This is the power supply of the board, and these are the power supply pins, and we can additionally take the power supply from these pins, and we have to give the input power supply to this pin, right? So if necessary, we can connect the LCD to here, and this is the reset button and this is the crystal. So we have to place the IC and take the IC and put the IC. So you have to detect the mark here, U-shape mark. There is a U-shape mark here, and controller is also U-shape mark here. These two U marks has to match. According to that, we can fix the microcontroller into the IC socket. So we can fix the IC like this, and these two are the motors that we are going to use in our project. Basically these two motors are 100 RPM motors, so we can connect these motors to the motor driver, right? And these are the IR sensors. The IR sensors are the key elements in this project. Why? Because it will detect the obstacles and it will give the information to the microcontroller. According to the information provided by these IR sensors, the microcontroller will take the appropriate actions. According to that, the motor will run and the robot will move, right? So let us going to take how the IR sensor will work, right? How the IR sensor will work, and this is the battery. That with this battery we can check the working of the IR sensor. So this is the IR sensor. Basically IR sensors having 3 pins. The first pin is ground and the middle one is VCC plus VCC. These two both pins are used to power up the IR sensor board, and the third one is this third pin is the output pin or output signal. So we can get the output from this signal from this pin. Okay, this output can be fed to the microcontrollers as input. So these are the pins. So let us check how the IR sensor will work. As this is the ground, this is the plus VCC. So we have to connect the black wire to the ground and red wire to the plus VCC, right? Okay. So I am connecting like this. So now see, there is no output in here. An LED is there. It indicates whether the object is detected or not. So basically this IR sensor is configured in active high logic. So whenever the obstacle is detected, it will give the positive logic and the LED will glow, right? So whenever the obstacle is detected, automatically the output becomes high at the output signal. So here LED is glowing. So no obstacle, no LED glow. Whenever obstacle is in front of the IR sensor, automatically the LED is glowing because object is detected. Like that the IR sensor will work. So it is connected in active high logic, right? So whenever object is detected, we can get the output plus 5 volts at the output terminal, right? So this is the working of IR sensor. So let us see how to make obstacle detection robot or autonomous robot. So see here how I am connecting like this. So take one. So take this. So put like this. This is the front side of the robot. So I have to fix this dummy wheel at the front side of the robot. And can fix this. Another wheel. Repeat the same procedure to fix the another dummy wheel to fix it to robot chassis. I fix the motors. So motors is having also the bolts. Remove the bolt first and put it in the hole of the chassis. put the bolt and make it tight by twisting it. Now take the another motor, repeat the same procedure. Repeat the same procedure here. Now two motors are fixed, two dummy wheels are fixed. Now fix the wheels. So this is the screw is there, and there is a hole to the shaft of the motor. So the screw should be fit into that shaft of the hole of the shaft. So put here like this. With the help of the screwdriver. Make it tight with the help of the screwdriver. And take another wheel. Repeat the same procedure. Now take another wheel. Repeat the same procedure to it also. Take another wheel. Make it tight. So now we fix all the wheels, and we need to connect the L293D board, and we have to fix the IR sensors. We have to fix the IR sensors. So put the screw here. And make the paste here. Fix the motor driver IC, right side of the microcontroller board, robot chassis, right, and let it cool until you fix it tightly, and take this back. This is the microcontroller board. This is the microcontroller board. So we can't fix this microcontroller board here. So fix the microcontroller board and robot. Testing it. Right. So like this, we can fix the microcontroller board and fix the IRs. So here we can fix the one IR. fix the IR, and fix another IR, and fix the another IR, and front side of the robot, front direction of the robot. So this IR will detect the front side obstacle, this IR will detect the left side, right side of obstacle, this IR will detect the left side obstacle. So now we have to connect the all these things with the help of wires and connectors. So let us connect. First, this is the motor driver, this is the motor driver, so we have to connect motor 1 here, and next we have to connect the motor 2 here. So we connected the two motors to the motor driver. Now we have to connect the power supply to the motor driver with the help of this 2-pin 2-side connector. So this is the plus 5 volts power supply and this is the ground. So now connect the power supply and take it from the hole on side. So these are the power supplies available from the microcontroller board, right? These are the power supplies available from the microcontroller board. Now we have to connect this to here. So we will connect the microcontroller, we will connect the power supply from the microcontroller board to the L293D circuit board. Now we have to give the inputs from the microcontroller board to the L293D board. So in port 0.02, port 0.3, these 4 pins are used to connect the or to give the signals to the L293D board from the microcontrollers. So get the motor 1 inputs and take it and connect this to the motor 1 inputs, right? And similarly take the inputs of the microcontroller for connecting the microcontroller board and connect these inputs from the outputs from the microcontroller board to the inputs of the L293D circuit board. So we power off the L293D board and we will connect the motors and we will get the inputs from the microcontroller board. Now all these things are being completed, and now we have to power up the IR sensors with the help of 2-pin 2-side connectors. So look at here. So these first 2 pins, this pin is ground and this pin is plus VCC. Now connect this and this connect here, because this is the power supply pins, this is the power supply pins. And now take the power supply from microcontroller board by connecting it like this, and similarly give the power supply to the IR sensor, second IR sensor. So this is the second IR sensor, and give the power supply to here by connecting this to here, right? Now we completed power supply, and here another IR sensor there, so we have to give the power supply to the another IR sensor also. So give the power supply, connect the pin, and now there are no ports or there are no power supply pins are available here. So power supply pins are available here on L293D circuit board, right? These are the power supply pins. So take the power supply from here and connect this power supply to this here. Now we provide power supply to all the IR sensors. So now we have to get the signals from the IR sensor. So this is the IR sensor 1, this is the IR sensor 1, right? So this is the IR sensor 1 output. So give the IR sensor 1 output to the port 1 of the microcontroller. So this is the port 1, this is the port 1. So IR sensor 1 output is connect to the input to the microcontroller ports 1.0 pin and take the output similarly from the IR sensor 2 and give to the port 1.1 as an input to the port and take the output from the IR sensor 3 and take the output from the IR sensor 3 and give the input to the port 1.2, right? We completed all these things. Now we have to power up this power supply. So this is the power supply. Now we have to connect the battery here, right? This is the power supply pin. We have to connect the battery here. This is the rectifier, which means bridge rectifier, and this is the 7805 IC, and this is the filter capacitor, right? So we'll complete all these things. Now we have to power up this microcontroller board or to power up the entire circuit with the help of the battery. We make all the connections. So we make all the connections correctly, but we need to alter the wires and to look good. So see here how we can make the wires look good. So this is a bunch of the wires. So take these wires and make a plaster here. So for good looking, make it like this. And this is motor driver IC. So we made all these connections, and we have to connect the battery to the robot. And so this is the power supply pin. Here we have to connect this battery to here, and there is a switch to the battery. We can, by using the switch, we can switch on or switch off the power supply. So put the battery here and connect this. So battery is in on position. So switch off the battery and make some glue here to the battery and paste it or stick it on the chassis of the robot. So we completed all the connections. Now we have to check the performance of the robot. Are you eagerly waiting to check the performance of the robot? Let's go, you can check the performance of the robot. www.takeoffprojects.com.